Question number 1. For two events A and B, if probability of A is equal to probability A given B is equal to 1 by 4 and probability B given A is equal to half, then which of these options are true? A and B are independent, A and B are mutually exclusive, probability of A complement given B is equal to 3 by 4 and probability B complement given A complement is equal to half. Let's go one by one. Let us see whether A and B are independent. This is the data available. If you look into this part, probability of A is equal to, writing the rule for this is probability of A intersection B divided by probability of B. Now, probability of A is already 1 by 4 and let us also look at that. Probability of B given A is equal to half implies probability of B intersection A by probability of A is equal to half. But already probability of A is 1 by 4. So, probability of B intersection A is equal to half into probability of A is 1 by 4. So, it is 1 by 8. So, let us come here. Probability of B is equal to probability of A intersection B by probability of A, which is equal to 1 by 8 divided by 1 by 4. So, this is equal to half. So, now you can see that probability of A intersection B which is 1 by 8 can be decomposed as half into 1 by 4, where half is the probability of B and 1 by 4 the probability of A. So, if you look at this statement, you can say that A and B are independent. So, therefore, option A is correct. Now, let us look at the other things. When you look at the option B, probability A and B are mutually exclusive. So, let us see what is probability of A intersection B. You know, it is already 1 by 8 and that is not equal to 0. Now, if you go back to the basics of probability theory, we say A and B are mutually exclusive if the probability of A intersection B is 0. That means the events A and B do not intersect, but in this case you get a non-zero probability. Therefore, option B cannot be correct. Now, already you have proved A and B are independent. So, when you go to option C, because A and B are already independent, probability of A complement given B will be reduced to probability of A complement. This is nothing but 1 minus probability of A, which is 1 minus 1 by 4 is equal to 3 by 4, which is perfectly all right. Similarly, in the case of the last option, probability of B complement given A complement, again because A and B are independent, A complement and B complement will also be independent. Therefore, this will be reduced to probability of B complement, which is 1 minus probability of B, which is 1 minus. So, this is half. So, again D is correct. So, therefore, this is a very fundamental question where all the basic concepts can be covered. So, we have the events which are independent but not mutually exclusive, and these probabilities can be easily estimated and they become easy to calculate because the events are independent. So, options A, C and D are all correct for this problem. Question number 2. A man is known to speak the truth 3 out of 4 times. He throws a die and reports that it is a 6. The probability that it is actually a 6 is. So, 3 out of 4 times he speaks truth. So, we can call this, let us say, E1. So, E1 complement will be 1 by 4. And then we have another thing, where he tosses a die and then he says it's a 6. So, that probability is 1 by 6, that it's not a 6 is 5 by 6. So, now the question is, we have got a person who has got only 75% chance of speaking truth. So, a 6 has occurred, whether really a 6 had occurred or not, this probability has to be estimated. So, you can easily apply the Bayes theorem for this. So, what you do is, you take 3 by 4 into 1 by 6 divided by 3 by 4 into 1 by 6 plus 1 by 4 into 5 by 6. This denominator is called the total probability. So, this becomes 3 by 24 divided by 3 by 24 plus 5 by 24. So, 3 by 8 is the probability that he gets a 6 and he says it's a 6. So, the correct option for this problem is B. Question number 3. 60% of a town are men and the rest are women. 30% of men and 70% of women speak the truth. A person is randomly picked and was found speaking the truth. What is the chance that the person was a woman? This is another classic application of the Bayes theorem, but we can also do it through a very simple tree diagram. So, suppose we have 100 people in the town, then if you break it into men and women, 60% are men, 40% are women. Now, 30% of the men speak the truth. So, this gets broken again into two branches, truth and not speaking the truth. Same thing happens in the case of women. So, 30% of 60, that becomes is 18 and the balance is 42. 70% of 40 is 28 and the balance is 12. So, in the whole population, 18 plus 28, that is 46 in the population speak the truth. Now, the question is, if from the whole population one person is picked and he is speaking the truth, so it has to come from one of these 46. What is the chance that the person is a woman? So, a woman speaking truth is 28. So, the required probability is 28 divided by 46. This comes to 14 by 23. So, option A is correct. You can also do this by Bayes theorem, which is an involved formula, but if you can analyze it through a tree diagram, Bayes theorem can be very easily applied.